Let's take a look at this problem. We have a real number a such that a to the power 5 minus a cubed plus a minus 2 equals 0. Find the value of the floor function of a to the power 6. Before we move on, don't forget to give a like, subscribe to our channel, and turn on post notifications. The first thing that I would like to do is to obtain more information about a. We only know that a satisfies this equation, or we can say a is a root to the function f of x equals x to the power 5 minus x cubed plus x minus 2. But for this function, in fact, if we try to look at its derivative, it is 5x to the power 4 minus 3x squared plus 1. And in fact, I can rewrite this as 2x squared minus 1 all squared plus x squared plus x to the power 4. So it's non-negative. So that means this function is always increasing. That means there is at most one real root for this function, and that would be exactly this number a. Now, for this function, notice that if I try to put some values, simple values, say 1, then we'll get minus 1. If we put 2, then we'll get 32 minus 8 plus 2 minus 2, that's 24, clearly positive, so we know that a is between 1 and 2. But clearly it's not enough because we are trying to look for a to the power 6. And 1 to the power 6 is 1, while 2 to the power 6 is 64. So the range is too large. So we have to try to narrow the gap of the range of a. Now we can try some other values, and somehow if you try 6 over 5, then the output is minus 124 over 3125, very close to 0, while if we try, then we get 357 over 1024. Again, a number that's very close to 0, but one is negative and the other is positive. So from this we know that actually a is between 1.2 and 1.25. The gap is now much narrower. And in fact, if we look at a to the power 6 from this range, we can see it's 6 to the power 6 over 5 to the power 6 and 5 to the power 6 over 4 to the power 6. For the fraction at the left, it's about 2.985984, while for the number at the right, it's easier to compute. In fact, it is 15625 over 4096, and we can say it's less than 4. So now from this we know that a to the power 6 is either a number that's between the 2.98 and 3, which makes its floor function equal to 2, or is equal to 3 because it's always less than 4. Now we kind of have a better understanding on how this value behaves, and we know that it takes exactly one possible value, and now we have to decide whether it's 2 or 3. To decide whether the floor function of a to the power 6 is equal to 2 or 3, we have to decide whether a to the power 6 is actually smaller or larger than 3. We can go back to the original equation, a to the power 5 minus a to the power 3 plus a minus 2 equals 0. I'm going to rewrite that as a to the power 5 minus a cubed plus a equals 2, and factorize the left side. So a times a to the power 4 minus a squared plus 1 equals 2, and I'm going to rewrite the left side as a fraction by multiplying a squared plus 1 for numerator and denominator. So somehow we have a much neater expression, a times a to the power 6 plus 1 all divided by a squared plus 1 equals 2. Now to establish some inequality on a to the power 6, we can try to do something on the other terms, a and a squared plus 1. Notice that a squared plus 1 is at least 2a. We can tell this because a minus 1 all squared is non-negative, always non-negative. So that means a over a squared plus 1 is less than or equal to 1/2. So from this, I can say this is less than or equal to a to the power 6 plus 1 all divided by 2. So that means a to the power 6 plus 1 is at least 4, and that means a to the power 6 is at least 3. And that means we can rule out the possibility that the floor function equals 2, and our final answer is 3. Please feel free to share ideas in the comments. Thank you for watching. See you next time.